Good morning. This is for our MAT264 review of exam number 1. So we're going to work through about 8 questions in this video. Again, kind of going in order. There's one I'm going to skip over because it's similar. And as you're having difficulties with one or another, again, you can fast forward into the video to the one that you need. As you can see, I've got the question numbers listed here. They're kind of in order of how they've appeared, and we'll just keep moving forward on them. Okay, so and in my screen I've got these the answers covered because in my system it always gives me the answer. So let's just go ahead and get started here. So this wants us to resolve this vector into its components, and what it gives us is it gives us the magnitude, and then we can see the direction of the vector here, the 36 degrees. So one of the things we'll see is that the picture here gives us whether x and y, which one is positive and negative. Obviously we see x is going to be positive, y's got to be negative because it's coming down into the 4th quadrant. So that's what this last little instruction's about. There's a little drop down arrow to put a negative there. And again, we can say, yeah, it's going to have a negative. Okay. But let's go ahead and do this one, and I want to tie you back as we go through here. This is our formula sheet. Kind of come down here a little bit. So this is what we have to work with, all the details, and we're going to use this one here with the trig. So we've got this triangle. Whatever angle this is, the components will be, the x component will be the magnitude cosine theta, y component will be magnitude sine theta. Okay, so those are the components, and then again we look at the drawing, the graph to see the sine values for x and y. Okay, so our component is going to be, our magnitude is going to be 10, so the vector is going to be equal to 10 cosine of 36 degrees. And that's the I component. We'll do plus 10 sine of 36 degrees. That's the J component. Now I wrote this plus, but then oh wait, let's look at this picture. Now the sine of 36 degrees is going to be positive. So maybe I shouldn't be too quick to just say it's always going to be plus, right? It's going to, this is a time, probably a good idea to say, hey, I know this is going to be negative. Now we just put this in our calculator and we'll get our values. So let me get my little calculator here. Of course, you could also use decimals. There we go. Or whatever you have. Take 10 cosine. Now one of the deals is you got to make sure you're dealing with degrees rather than radians, and so here I go to my mode. I'm in radian mode. See, I would have gave me the wrong answers and I would have said what's going on here. So make sure if you're doing degrees you're in degree mode, and then everything will be just fine. Cosine 36. So that's going to give us 8.09 I round to 2 decimal places minus, let's go with 10 times the sine, 36 degrees. It's going to be 5.88. And that's our J component. So we've got it into the components here. Let's check our answer. 8.09, 5.88, and notice the negative has been chosen. So make sure you do all of that as you're going through these. Okay, that's our first one. Incidentally, I'll save these. Get this stuff out of the way. And so those will be available as well. Okay, here we're given two vectors, v and w, and we're asked to calculate the following. It's right down here. So notice there's a scalar times v, so we'll do that part, and then you're going to subtract the w and subtract the v. And when we're doing algebra with vectors, it's really component by component that we do things. So we'll first do this 9 times the vector. So we've got 9 times 8i plus 5j minus 8k. I'm going to dispense with the little arrows on top. And then we're going to subtract w. So that's 6i minus 6j plus 8k. Notice this negative has to distribute through here, and then we have a final minus v, so I'm just going to write that one. Minus 8i plus 5j minus 8k. Okay, so now distribute through the 9, so we get 72i plus 45j minus 72k. We distribute negative 6i plus 6j minus 8k, and distribute again, minus 8i minus 5j plus 8k. So now it's just arithmetic, adding. I mean, this has already been arithmetic, I guess. You know, distributing is really arithmetic. I see a minus k and a plus k, so okay, that makes my negative 72k is what we're going to get. Made that easy. This is not going to be quite as easy, but I see a minus 5 and a plus 6, so there's only going to be 1j, so I'm adding 1j to plus 45, so that's going to be plus 46j. Okay, so I've taken care of the j's all together. And then negative and negative subtracting 2, so that's going to be a negative 14. Here's a positive 72. Okay, so I just need to do this, and that's going to give me a borrow 12 from 12 is 8. 58 I, and I'll put my little arrows now at the end to make it nice and pretty. So that should be our answer. Let's see, I think I have to go like this. There we go. Get to the right. Looks good. 58I, 46J minus 72K. Let me get rid of my little stray marks here. There we go. Okay, and again, I'll move this over here. We'll save this. Just arithmetic with vectors. Okay, we've got 2. What we need to do is we need to add the vectors and find the magnitude. Remember, magnitude is a scalar. It's a number. Okay, first of all, adding 2 vectors together, you just add their components. Okay, so we can do that right here. Let's go with the blue. 9 plus 9, that's going to give us 18I. And then 4 minus 3 is going to give us plus 1J. And I'm going to write that 1 just because we're going to need that number. It's not 0, it's 1. Okay. Then negative 7 and negative 2, we're getting more negative. That's going to give us a negative 9. Okay. So that's our resultant vector. To get its magnitude, It's basically like the, remember that comes from the Pythagorean theorem. So we square each of the components and add them together. So 18 squared plus 1 squared plus negative 9 squared. So 18 squared is something I don't have memorized. We're going to need to do a square root anyway, so why don't we just go ahead and put it all in here. So we'll do 18, so let's turn it on, clear. Let's go ahead and pull up the square root, which is right here, the square root, 18 squared plus 1 squared, I'll just put it as 1. And 9 squared, I know in my head is, I was going to say 72, but 9 times 9 is 81. 81. So sometimes, oops, something happened here. There we go. Plus 81. So sometimes it's valuable to just go ahead and, you know, I put your 9 squared there. So the total should be, and they want 2 decimal places as usual. Oops. Come back here. So 20.15. And hopefully, oops, I keep forgetting. I'm going to do that one and get out of the pen mode. .15. We're doing it. Okay, so now we're down, I think it's about question 4. We're doing a dot product. And remember, a dot product actually is a scalar. It's a number. And what we do is we multiply the component parts together, the matching components, and then add the three, in this case, the 3 dimensions. We add each multiplication product together. So we, let's see. Let's come to this one. So we're going to take 4 times 7. We're going to add to that negative 6 times negative 7. And we're going to add to that 9 times negative 5. So that's 28. That's positive 42. That's actually going to be negative 45. So actually, I'll do these two because they're so close. A positive and negative is actually going to be negative 3. So take 28 minus 3 should give us 25. And that's it. $25. Dot products, not too bad. So down to, let's label this question 15 here. I think number 5 for us. And now we're asked to do a cross product between a vector and itself. Now we're going to see a property that, if we remember, will make it really quick for us to do this. But instead of just jumping to and say, well, this is the answer because this always happens, let's go ahead and work through this together. Again, if you didn't skip this video, this is probably something you want to learn. So remember, to do a cross product, we sort of make a matrix. And so it's going to be 7, 8, negative 5. And we're doing it with its own self. So it's the second vector is 7, 8, negative 5. And then to do the cross product for the I component, you're crossing the j and the k components, right? So that's 8 times negative 5 and negative 5 times 8. So this is for the I component. 8 times negative 5 minus 8 times negative 5. Eight times negative 5 is negative 40 minus negative 40. Negative, negative, make positive. Negative 40 plus 40, that's 0. We're going to see that pattern kind of comes through. So for the j component, we take the I and the k. So we're going to take 7 times, but remember, we kind of do it backwards. The one that comes first is going to be negative 5 times 7. Should have given myself a little more room. Let's do that. So it's going to be negative 5 times 7. Let's go with a different color. Minus 7 times negative 5. Now, again, in this case, it doesn't really matter. But I just we want to be consistent so that when we do it, it all makes sense. So negative 5 times 7, that's going to be negative 35. 7 times negative 5 is negative 35 with another negative, so negative and negative actually make it plus 35. And yes, you got it. It's a 0. And you're right, the same thing's going to happen for k, but just sort of to do k, we're going to cross the I and the j. And so this time we start 7 times 8 minus 8 times 7. You can kind of see why a vector crossed with itself is always going to be a 0 vector. Okay, this is 56 minus 56, which is 0. Okay, so that's our setting there. And so now in the future, you'll be able to just say, oh, a vector cross with itself is going to be 0. And that's pretty much the description they gave. But I wanted to go through the process. How do we do a cross product? Okay, so good property to remember. And now let's do some cross product with a dot product. Now again, we're going to see maybe something here, but again, if you look up their explanation, it just might seem like they're making something up, or they have some knowledge. We'll actually go ahead and go through the process so that we're able to know how to do a cross product with the dot product and see what we end up with. Now, there are some properties we could distribute this over, but I think it's going to be easier. Just let's do this cross product first, and then when we get that, we'll go to the dot product. So the cross product, again, just like we did, we set up a matrix. So we go with I, j, and k components. So we've got for the v vector, right, we're going to have 1, 5, and 7. And for the w vector, we're going to have 6, -9, and 7. Now there's something when these components of 7 are the same, it's telling us something. Okay, and so let's do that cross product. Okay, again, cross product for I. We cross the I and the k, so it's 5 times 7 minus 7 times -9. I'll just write them out. That's going to be our I component. Let's just go ahead and write it all out. Plus the j component. J component comes from I crossed with k, but backwards. So we first do 7 times 6. And then we subtract 1 times 7. That is the j component. And then for the k component, we cross the I and the j again, starting from the upper left-hand corner. 1 times negative 9. It's negative 9. Oops. It's messy. Messiness is not good. That's where I usually make most of my errors, is if, so 1 times negative 9. So sometimes, yeah, it's just easier to go ahead and write the negative 9, but I just want you to have a record of where things are coming from. So 1 times negative 9, and then 5 times 6. Okay, so this is 35, negative and negative is going to be a plus 63. This is 42 minus 7. It's a j component. And this is negative 9 minus 30. And then we combine 98. This is 35. And this is negative 39k. Okay, so that's this part of the problem so far. Now we need to dot product it with w. So we take this vector, dotted with w, which means that we component by component, right? And let's see, that's going to be, I'll just write down the w here. So we'll go 6i minus 9j plus 7k. So we take the I components, we multiply them, and then we're going to add the j components multiplied together. So it's 35 times negative 9, and then the k components, negative 39. Oops, I copied something wrong there. This is 35. And I think I said 35, but I think I looked too quickly at the 39. 35. This is another reason to write down each step of the process. Okay, so we got some larger numbers here, so let's go ahead and pull up the calculator. 98 times 6 while we're at it. It's 588. 35 times negative 9. It's negative 315. And then 7 times negative 39 minus 273. Now watch this. When we add these two together, what do we get? So 315 plus 273. That took their signs off, but notice it's 588. So this is 588 minus 588, which all equals 0. And remember, a dot product kind of told us that we'd get to a final number. And yeah, and if you look up the explanation, they say that these are perpendicular to each other, and I think because of the k. So when they're perpendicular to each other, if you cross product with the dot product, you're going to get 0. But just, I don't remember seeing that as a property in our discussions so far. So, and nor would I don't think I would remember that. So anyway, knowing how to do a cross product with the dot product, and then when you get this, hey, these vectors are perpendicular, they're orthogonal. Okay, I think I've got about 3 more to go. Find a normal unit vector to this plane. Okay, so the vector to this plane, a normal vector, would just be 6i. Sorry, wrong place here. Would just be 6i plus j minus k. Like this, minus 1k. So this is the equation of the plane. To make this a unit vector, what we have to do is we have to divide by the magnitude. I'll get there. Okay, and remember the magnitude is just you take each component, square them, and add them together. Square root, so from the Pythagorean theorem. So this squared plus this squared plus that squared. So we get 6 squared plus 1 squared plus negative 1 squared. So it's going to be 36 plus 2, which is square root of 38. And we're just going to leave it like that, so we divide each of these by square root of 38. And lo and behold, put a 1 there, put a 1 there. There's our unit vector. A normal unit vector to the plane. Remember, this is, which means it's 90 degrees to the plane. So that when we have its equation, this vector is normal to the plane. This vector. Sometimes I'm sorry, I got 2 screens going, and sometimes when I point, I'm actually pointing to my recording software, which doesn't show up on the recording. So we see it looks a little nicer here, but it's divided by the magnitude. Okay, so that's good because there's a number of situations we're going to need to find the unit vector. But for now, we got through the first unit, so keep on making your progress. Wednesday, we'll have time to go over, answer some questions back and forth, but this will be our first one to take a look at. So thank you very much. Keep up the good work.